Let's start with our first tutorial, that is adding CAD parameters to CAD parts. So this is the PDF which is available in the installation directory, and you can go through it. It contains each and every step that one need to follow. I'll quickly go through it. So you can see here we are going to work on this coupling FEA assembly. So it has some parts like left hub, right hub, some pin like structure is there, bottom plate is there, and some part representing loading location. So we are going to see this assembly and we are going to add CAD parameters, that is we are going to do tagging for this assembly. So tagging basically means assigning simulation component and simulation classes to CAD parts. So simulation component represents the geometry, whereas simulation classes, it represents the solver physics which is recommended by lead analyst. So you can see here there are some tables given in this PDF. So it shows CAD parameters and their respective values and the part on which it needs to be assigned. So we'll be referring these tables to add CAD parameters in coupling FEA assembly. So you can see a coupling FEA assembly here on the screen. So I have opened this in Creo modeler. Again, I've taken this data from the scratch folder which I have already talked about, and you can see here under this assembly there are some parts highlighted or the parts shown in the model tree. So let's see how one can add the CAD parameters to this left hub part, for example. So for that one need to go in this tool, then in this parameter, then you can see here there are some options available. So one can add the CAD parameter at part level, at surface level, or at edge level. So based on requirement you can add it. I'll just select here part level, then one need to click on this arrow. After that I'll just select the left hub part in this graphical user interface, then I'll click on this plus sign and I'll just type here SCOM. So that is simulation component which represents our geometry. I'll set type as a string and I'll give name as left hub. Similarly, we'll add simulation class also. So S class stands for simulation class and it represents the solver physics which is recommended by lead analyst. I'll set type as a string here and I'll give value as solver. So likewise, one can keep on adding the simulation classes based on the physics. Then I'll click OK here. Now one can see the added CAD parameter in this model tree. So for that one need to go in this setting and add some columns. So just click on this tree column. I'll select here model parameter and I'll type here as SCOM. Then I'll click on this arrow. Similarly, I'll add S class type here. I'll click on this arrow and then I'll click on apply and OK. So you can see here the added CAD parameters, now those are getting reflected in the model tree. Now henceforth you can use this model tree to add the CAD parameters to other parts. For example, for this right hub, if I want to add simulation component and simulation classes, then I'll directly click here in this model tree. So when I click here, it will ask me for the type of the value which one need to enter. So I'll just write here right hub. I'll click OK. Again for S class type, I'll again select the type as a string and write solid. So this way one can keep on adding the CAD parameters through the model tree. You can see here now we have added all the CAD parameters on all the parts. Again, this is in line with the table given in the PDF. Now we'll see how to add the CAD parameters at surface level. So for that, one need to go again in the tool parameter. Then we need to select the surface here now instead of part. Then click on the arrow and select the surface in the graphical user interface where you want to add the CAD parameters. So I'll just select this bottom surface. Then I'll click on this plus sign. I'll give scom, that is simulation component, with type as string. I'll give bottom face com. Similarly, I'll add S class BC here because I want to constrain that bottom face. I'll just select type as a string. I'll give value as fixed tool and I'll click OK. So this way one can add the CAD parameters at surface as well as at the edge level. So you can notice that the model tree only shows CAD parameters given at part level. It will not show the CAD parameters which are given at surface or at edge level. Now after adding all the CAD parameters, we need to save the CAD model. Otherwise, all those CAD parameters will not be saved. So make sure that you are saving the CAD model after done with the tagging. Now let's see how one can save this model tree. So for that we need to go here in the settings, just click on export setting file, then set type as a configuration file and you can give any file name. I'll just give here tree.cfg and I'll just save the file. So this way we are saving the model tree. Now next time when you will open this coupling FEA.assembly and if you don't find the model tree here, then you can import the earlier saved tree.cfg file. So for that one need to again go here in the setting, click on import setting file, set type as configuration file. You can select that earlier saved tree.cfg file and you can click on open. So this way you can see all the simulation component and simulation classes which were present in that tree.cfg file. Now one can edit this model tree based on the requirement and again save the tree.cfg file. So that's all from this first tutorial. So we have seen how to add the CAD parameters onto CAD parts, and please note that unless and until you save the CAD model, those parameters will not get saved. That's all from this first tutorial. If you have any queries, then please feel free to contact support@novusnexus.com and we'll get back to you accordingly. So thanks everyone and see you in the next tutorial where we'll see how to import the CAD parameters in CAENexus.